Hello and welcome to another one of D's ADD videos. Today we're going to be looking at factoring out higher order polynomials whenever the power of x is greater than 2. What do we do? What's different in that type of scenario? Well, first thing you should do is you should try to factor out the highest common term. Okay, if you forgot how to do that, just go back and check out the videos. Example videos and concept video and practice. That's something you should definitely know how to do by now. If that doesn't work, let's say you have 4 monomial expressions in your polynomial. You could try factoring by grouping. Sometimes you can pair them up in such a manner where there's something common to the first 2 and the last 2. And what's left when you factor out those terms is something similar which can be factored out itself. If you don't know that method, go back and check out those videos. If neither of these work, then you try your P over Q method. What is that? Well, let's take a look at this polynomial here. This is the highest term, the degree term with its leading coefficient of A, and this is the constant term. Okay? Based off of that, these are the steps. First, you're going to find your P's. And the P's are going to be the factor of your constant C, and basically you're going to list them all out. Okay, for instance, let's take a look at the number. Let's say our constant was 4. You'd have, if C here was equal to 4, and your list of P's would be plus or minus 1, plus or minus 2, because 2 times 2 is 4, and plus or minus 4, because 4 times 1. And you have to do the plus or minus because you can get a positive 4 by doing plus 1 times plus 1, or minus 1 times, or sorry, plus 1 times plus 4, or minus 1 times minus 4. Either way gives you a plus 4 answer. And then you do a similar type of factoring there as you did with your C, but in this case you're going to use this A over here. And what you do with the A, let's say A was 3, you would do the same thing basically. So this would be for this one. A is equal to 3. You would have Q would be plus or minus 1, plus or minus 3. Okay? So this is coming, that's sloppy, let me rewrite that, sorry. And that's supposed to be a Q. I don't like any of that. So Q is plus or minus 1, plus or minus 3. There we go. So then what you do is you create a list of P over Q, all right? And you don't need any repeats, all right? So in this case, it would be all of P over Q, would equal all the numbers in P, 1, 2, and 4. And then you would have semicolon, when you do P over Q, when it's 1, that's when you get all your P terms. But then when it's 3, you get a few new terms, right? What do you get? You get plus or minus 1/3, plus or minus, trying to squeeze this in, sorry, 2/3, and plus or minus 4/3. Okay, so in this random scenario, I didn't have a polynomial, just where C is 4 and A is 3. Your P over Q list would be all of these numbers, the P list that we have here, so these numbers. Then when you do over 3, you get these 3 new terms there. All right, these are the candidates for your roots of your polynomial. So when you factor them, these are the possibilities that you could have. So what do you do after you find these P's over Q's? There's 2 ways you can do this. Some people prefer one, the other one prefer the other method. So just pick one and just keep doing it. First method is you're going to plug all these P's over Q's into the polynomial, and when you get a 0, that's when you've actually got a root. Okay, then you can use synthetic division. So basically you're using the factor theorem that says that when you plug in a number into your polynomial, you get a 0, it's a root. So in this case, don't start with the 4/3, don't start with the 2/3, start with the +1, the -1, and then work your way up, if you have to the more complex roots. Or more difficult. I don't want to say complex and have you think imaginary numbers. I'm talking about complex roots in the sense of 1/3 or 4/3 is much harder to plug into your polynomial than a 1 or a -1. All right? The other way to do it is just start doing synthetic division until you get a 0 remainder. And once you get a 0 remainder, we know it was a root. Okay? Either way, you're doing synthetic division at the end, and you're going to keep repeating that synthetic division step 4 until you get a power of x squared. Once you get a power of x squared, then you should be able to factor by grouping or guess factoring, however you do it, whatever makes you happy. And then you should be able to either find all the zeros or list out fully factored roots. Okay? So again, find your p's. Actually, first, try to factor out a common factor, then try factoring by grouping. No need to bring out the tanks if you can get them with just, the front lines or the lighter weaponry. So, if that doesn't work, then bring out your tank. The last resort, I guess, is your p's over your q's. So first list of p's. P's came from where? The constant here. And then q's come from a. And then you do a list of p's over q's. Those are your candidates for your roots. And then you plug them into your polynomial until you get 0. And use synthetic division over and over. Or just use synthetic division until you get a 0 remainder over and over until you get a quadratic term. Then factor. Okay? So make sure you check out the example videos dealing with the factoring out of higher order polynomials. Practice is the most important thing. And thank you and have a nice day.